Hi, everyone. Today you'll see the title at the top of the screen. What we're going to discuss is linear and nonlinear relations. And so what you'll see in that top little blurb, if you're following along with that written lesson, is that what we're going to do is we're going to look at both the graphs and the equations of different types of relations, with our whole goal today being able to determine is something linear or is something nonlinear from both those forms. So if given a graph, can we figure out if it's linear or not? If given an equation, can we figure out if it's linear or not? So the first thing I want to maybe draw your attention to are the first three graphs that you see on the top. And I should say the first three set of axes. We happen to have two of the same type of relation on the first set of axes. So when you guys take a look at that first set of axes, I just want you to notice that that black line that you see, that curve would be described as an increasing graph. And notice that as we take a look at that, we can see that it is linear because it is a line. Now, sometimes people go like, you mean a straight line? And I'm like, well, guys, by definition, a line must be straight. If it's not straight, then it's a curve. So we don't ever say straight line, we would just say a line. So the way we would describe that black line then is we could say that that is an increasing line, because as we move to the right, my line goes up. So if we're okay with that then maybe we can see that that blue line that you have would be described as a decreasing line. Still a line, but we could describe it a little bit by the direction the line goes. You'll notice what we have in that second set of axes. That would represent our horizontal line, and that is always one of the ones where we go like a straight line. And we're like, no, look, all the lines on the first set of axes are straight as well. But what we're really describing is a horizontal line. Please make sure you spell horizontal correct. And then that should leave us with that last line, and we should be good that the last line would be described as a vertical line. So if we've got that as our four options really for what a line could look like on a graph, then I think we're good at being able to tell them apart. What I want to do is just quickly jump to some really common nonlinear graphs. So again, if you're following along in that lesson, I've put a quick sketch down for what each of those functions could look like. And so you'll notice in the top left corner, what we have is a quadratic function, or what's often called a parabola. When you guys move into grade 10, you deal with an awful lot of quadratic problems. Now, all of your parabolas don't have to look exactly like the blue one given. You could end up seeing a parabola that took that shape as well. Maybe we see that parabola and it's over here somewhere, and so on and so on. You take a look at your cubic beside it. That is just one example of a cubic. We could also have our base cubic function that I'm going to put on as the new curve in red. You'll notice a little bit of a difference between our cubic and our quadratic. Our quadratic, and I'm just going to highlight the first part of our quadratic, maybe starts to decrease and then it increases afterwards. Where you may notice that our cubic may start to increase, and instead of turning back around and decreasing, it continues to increase just on a different curvature. So those are all examples of cubics. You'll start to address cubics in grade 11 and grade 12. Well, you take a look at your two examples of exponential curves on the bottom, and I'm just going to slide that up just a little bit. And I wanted to put on two different options for your exponentials because sometimes people really start to confuse an exponential with a quadratic. And we just need to notice that there is no change of direction. And so if I was to just highlight that exponential, my exponential curve can take off and go really, really steep, or B, really steep and then start to level off. So, just a number of different options for us when we discuss nonlinear. The focus for today is really, can you tell the difference between a linear graph and a nonlinear graph? It's not really, can we tell the difference between a quadratic and an exponential and a cube? No. We really want to be able to divide them. Is it a line or is it a curve? Okay, we're going to jump into kind of the next segment of this lesson. What you see at the top of your page there is now going to be just a quick instruction that the equations below represent 4 different kinds of relations. It then says that we're going to use Desmos. And so you guys see Desmos. And we're going to sketch the graph of each relation. Now, I'm going to argue to you that for the purpose of what we're doing right now, we don't need to sketch the graph of each relation. You may choose to, and what you see on the bottom half of your page are sets of axes that break up those different relations into 4 categories. What I'm going to do is I'm going to suggest that we use Desmos, because Desmos is going to save us a ton of time. That rather than us going through and doing a table of values for all of those different types of functions, what we're going to do is we're going to go through and we're going to use some graphing software to do it for us. So before we hop in, then let's jump in and see what this whole Desmos thing is about. So the first thing that I want to draw your attention to is there's your address for how you guys can get onto Desmos. So what you can either do is open up a new page in your browser, a new tab, and you can type in that address. Or if you go to our Brightspace homepage, you're going to notice that on the nav bar, you're going to see an icon that's in green that says Desmos. If you select that, then it's going to take you straight to our graphing software. And so when we get to this page, what we will have the option to do is to be able to go through and graph functions really, really quickly. So if you look back to the top of that whole list of relations, then you're going to notice if we go to the top left, you're going to have y equals x squared first. Okay, well, rather than going through and doing a table of values, I'm going to type in y equals x squared. And so if you take a look, that menu on the left is going to enable you to go through and enter in a function. So this is where we enter in our functions to graph. So I'm just going to get rid of that circle. And what I'm going to do is I'm going to enter in, just as my graphing calculator resets, I'm going to enter in then y equals x, and then I need to put an exponent 2 on it. So I can hit, if I choose, my a squared button, because that a squared button is going to be my default squared exponent. So I can hit my a squared, and there is my graph. Now, there are other relations that you see on the page that don't just have exponents of 2. And so what some people will choose to do then, if I just delete that squared, is they may choose to use the generic exponent button. And that's what you see there with your a to the exponent b. That if you want to punch that button in, then it's going to put you up into a generic exponent, and I can now select 3 or 2 or 5 or any exponent that I want. And so some people like to use the generic exponent button, because then they just get to use it all the time. So there is us going through and punching in a function. Now, if you like that relation coming up on your screen and you want to include another sketch, then you can put that based on its category, and hopefully we can see that that would be a type of quadratic relation. So you can draw that quick sketch, if you choose, on that set of axes towards the bottom of the page, the middle of the page, I guess. But you don't need to. Our focus today is, can we tell what types of equations give us lines and which types of equations give us curves? So I don't really care today whether that gives me a quadratic. What I care about is it's not a line. Okay, so what I might do then is I might go through and I might then start to punch in different equations. So I'm going to maybe delete that whole equation. And Desmos will just have to pop back in here for one more second. There we go. And I just need to delete that. We just got a little delay on Desmos. There we go. And so what we could enter in on the next one would be my y equals x to the exponent 3 plus 4. I notice that one is not a line either. And so maybe then, well, maybe I just keep that on and I want a new graph. Well, Desmos allows me to actually graph multiple relations. So maybe on my next line, I'm going to punch in y equals 5. And now you notice that my exponent in this case is x. So I need to hit my generic exponent button and then an x. And now I get my blue curve. Now, as soon as we start to put multiple curves on, it may get a little confusing to tell them all apart. I want everyone to take a look up to the top right corner, and you'll see that little wrench. That wrench is our tool, and what it's going to do is it's going to take us to a menu. That menu is going to pop up to something like this. And there is an awful lot of detail on there that we really don't need for our purposes today. But one of the things that we may like is if you hit projector mode and then select somewhere else, you'll notice it makes all your lines thicker. So that can be a little bit easier for us to go through. Now, if you select, there's our curve. So maybe we start to work our way through and we say, hey, I want to put another function on. And now I'm going to punch in y equals, well, my next one going across would be 3x plus 1. And I noticed that I just got a line. That was the focus for us today. When do I get lines and when don't I get lines? So you can, if you wish, go through and produce little sketches of each one of these relations down on the 4 sets of axes below. Or what you can do is spend your time saying, I can tell the difference between when I get a line and when I don't, and that's what I'm going to draw my attention to. So what I'd like us to do then is I'm going to pop back onto that handout to show you how you can make use of that handout. So now my list of relations looks a little different than yours, and it's just because I had to space them out a little bit and to get them to fit on the screen. But you'll notice that we have all the same relations. What I might do is I might simply go through and use Desmos to very quickly say, nope, y equals x squared did not give me a line. Y equals x cubed plus 4 did not give me a line. Y equals 5 to the exponent x did not give me a line. Y equals 3x plus 1 did give me a line. And then slowly work your way through and just use Desmos to speed up the process. How do you feel about y equals 2x to the exponent x? What about y equals 1/3 x? What about y equals 1/3 to the exponent x? What about 3x? And so on and so on. So I'm going to ask you guys to pause the video now and just work your way through that whole list of relations on Desmos. I would recommend after a while, though, delete some of the pictures. Like, you can keep putting on a bunch of graphs, but if all of a sudden you start to have 15 graphs on the same set of axes, it gets really difficult to tell them apart. Okay? I would say it should probably take you maybe a few minutes to work your way through Desmos to get pictures, but let's go through and let's highlight, let's circle, let's draw to our attention which types of equations give us lines. Okay? Pause the video now. Okay, and so we're back. And so hopefully, if we had to go through, that we should have encountered that. And I'm hoping that our list of relations, we have the same list of ones that we've crossed out that gave us curves and others that we've circled or highlighted that gave us lines. Okay, if that matches up, then again, if you drew pictures on the bottom to give quick sketches, then that's great, not needed. What I want us to do then is I want us to turn the page and take a look at the top portion of the next page. So what you have is compare the equations of the lines with the equations of the others. How are the equations of the lines similar or different from the equations of the curves? And now we get to the meat of the problem. So as you analyze, okay, what was the same about all of the equations that were circled? What was the same about all the equations that were crossed out? Can we start to get to a point where we could create a statement that would allow you to recognize whether an equation gives you a line or not? And so what we want to do is we want to finish off a statement that says, an equation graphs a line if. Okay, could we finish off that statement? So I want you to pause the video now and just take a shot. See if you can come up with something with some decent detail. Okay, pause it now. Okay, we're back. So hopefully we were able to kind of work our way through a little bit, and we kind of got nailed down to a couple key things. One of the things that I'm hoping that we drew our attention to, and I put it in your actual wording, pay particular attention to the exponent on your x. So let's see if we match up somehow with part of this statement. An equation graphs a line if the exponent on both x and y is 1. Like, I think that's a pretty decent statement. And if we have that, then I think we're doing pretty good. My guess is I would have had a bunch of people that simply would have written when the exponent on x is 1. And I want us to see, and we will coming up, that maybe that blue statement about the exponent on both x and y starts to be a little more complete. It's still not totally complete because we need to finish it off with when both variables are present and y is isolated. Okay, we want to get into an instance where we're going to take that blue statement and we're really going to break it down. Your statement of what was underlined, when the exponent on x is 1, is going to get challenged a little bit. And I think it's good that it gets challenged. What I want to do with the bottom of that page now is we're going to work our way through. I give you an equation, and without graphing without using Desmos, we're going to go through and we're going to examine, does that form a line? Okay, here we go. So what you now see on that page is we have a number of relations. These will match with the ones that you have on the bottom of your page. And what we're going to do is we're going to go through and we're going to examine, would each of those be linear or nonlinear? So, is it a line or is it a curve? Okay, let's take a look at A. Y equals 4x plus 5. I want you to write down an L or an N below that to denote line, linear. Put down an N for nonlinear. Okay, if we take a look back up at our definition, I'm hoping that most people came in with an L. Look at your exponents on both your x and your y. Notice my y is isolated, and my exponent on x is 1. So there's my line. Okay, I want you to go through the next stream of problems, B, C, and D. And then I want you to stop at the end of D. Okay, y equals x cubed minus 1, 2 equals negative y minus 4x, D, y equals x squared minus 1x minus 5. Answer all three of those. Put down an L for linear or an N for nonlinear. Okay, pause the video now. Okay, we're back. I'm hoping that as we took a look at B, we noticed I have an exponent on x that's not 1. And so pretty quickly, we said nonlinear. Okay, C. Well, in C, I see an exponent of 1 on my y and an exponent 1 on my x. And so we should have pretty quickly said linear. Now, you will notice that your y is not isolated. But if I was to get that y all by itself, then that would equal negative 4x, and then I got to get rid of that too. We should be able to see that when y is isolated, the exponent on both is 1. Okay, on D, we were really quick on D because you saw that you had a squared on your x, and as soon as you see an exponent that's not 1 on there, then you know that we are nonlinear. Okay. Now what I want you to do is I want you to jump through the next 4. Okay, you go through and you tackle the next 4. E, F, G, and H. So let's pause the video now. Okay, we're back. So I'm hoping that we have this. And if we have that, then we match up pretty well. However, I'm going to bet and say we don't really have that for everything. So, a couple quick comments on each one of these. Take a look at E. Notice we don't even have an x, but we're okay with that because we know that when that says y equals negative 4, that means your y value is always negative 4. And so on my graph, the only place where my y value would always equal negative 4 would be a horizontal line. So nice, we've got a line. You take a look at F. As soon as you saw the squared, you knew it was nonlinear. Nobody got thrown off in G that I can have a fraction in there. There's nothing wrong with fractions. My exponent on my x was 1 when my y was isolated, so its exponent was 1. And now we come to H. I would have expected an awful lot of people on H to have written down that that was linear. Because I want you to notice that as we look at that, we might go, hey, look, I have an exponent of 1 on both my x and my y. However, we might now see the importance of answering the statement when y is isolated. If I go through and I isolate my y, then that means that I have to get rid of my times by x, which means that I divide by x. Now, some people are going to look at that and say, But I still don't have a problem with that because look, my exponent is still 1 on both. And we've actually made an error there. Your exponent on x really isn't 1. If you recall, that x is on the denominator. And so I need to get that x out of the denominator. That means I have to move that x across its fraction line. And when I move it across its fraction line, it changes signs on its exponent. Y equals 2, x to the exponent negative 1. Now we can see that my exponent on my x really isn't 1. It was negative 1. And because of that, it's not a line. We're nonlinear. Okay, if you're doubting me at all, go ahead and punch xy equals 2 into Desmos, and you're going to see a lovely graph that looks something like this. Definitely not a line. That's your hyperbola. You actually start to examine that in grade 11 university math. But for us now, that's not a concern. All we know, that is not a line. Okay, I want you to deal with that last row again. So this will be a good gauge for us. You work your way through and try to put down a guess or a good estimated guess on what the rest of that row is. Okay, give it a shot. Okay, and now we're back. And so when we take a look at that last row, I should be able to quickly go through and say, well, this first one is nonlinear because you notice that you have a squared on your y. We take a look at j, and this one might be a little tough. I threw this one in there because we may look and go, hey, they both have exponents 1. However, what we don't realize is that exponent 1 on that x is underneath a root. It really doesn't have an exponent 1 on it. It's the square root of x plus 4, and that gives us a nonlinear graph. Again, feel free to punch it into Desmos to get a little confirmation. On k, well, you got a cubed, you got a squared. We have so many exponents that aren't 1 that pretty quickly that one is nonlinear. And then we take a look at L, and for L we have y to the 7 to the exponent x, and we go, oh, wait a second. My exponent isn't just a 1, it's an x. My x isn't even on my main line. Oh, well then that one's a nonlinear. And what we would actually find is that we get an exponential curve. Okay, hopefully that gives us a little bit of something to be able to go through and identify whether a graph is linear or nonlinear and whether an equation is linear or nonlinear. So your job now, jump in and get some more practice going through and cranking out. Can you identify a line or a curve? Okay, good luck.